We now learn how to find the mean as well as the mode of a discrete random variable. Let's say we're dealing with a discrete random variable, which we'll call capital X, and it has the following probability distribution table. We're asked to find two things. The first thing will be the mode, and secondly, we need to find the mean of this discrete random variable. Now, to find the mode, it's important to keep in mind that all the mode actually corresponds to is the value that the discrete random variable, capital X, is most likely to take on. So to find it, all we need to find is the largest probability that we see inside this table. And looking at this table, it doesn't take us long to see that the largest probability we have is 4 over 10. And this probability corresponds to the case where the discrete random variable equals to 4. So we have the answer. The mode is 4. So I'll just write mode, 2 dots, capital X equals to 4. And I'll just go ahead and underline that answer. Done. We now need to find the mean. And to find the mean, we're going to need a formula. And the formula for the mean of a discrete random variable is the following. Mu, which is the Greek equivalent of m as in mean, is equal to the sum of the products of lowercase x with the probability that capital X, the discrete random variable, equals to that value of x. Looking at our distribution table here, we can see that the discrete random variable capital X can take on either of the values 2, 4, 6, and 8. So this sum would turn into the following. It would equal to 2 times the probability that capital X equals to 2, plus 4 times the probability that capital X equals to 4, plus 6 times the probability that capital X equals to 6, and finally plus 8 times the probability that capital X equals to 8. And here's one of the advantages of always writing the distribution inside a table. We have everything we need for these products right in front of us in this table. Indeed, 2 times the probability that x equals to 2 is just 2 times 3 over 10. Similarly, 4 times the probability that x equals to 4 is just 4 times 4 over 10. And 6 times the probability that x equals to 6 is 6 times 1 over 10. And so on. And so all we're doing each time is just multiplying the x value with the corresponding probability. So this sum turns into the following. It's equal to 2 times 3 over 10 plus 4 times 4 over 10 plus 6 times 1 over 10 plus 8 times 2 over 10. That's equal to 6 over 10 plus 16 over 10 plus 6 over 10 plus 16 over 10. And adding all of those together, we find that that's equal to 44 over 10. And we can write our final answer as mu is equal to 4.4. And we're done. We've just calculated the mean of this discrete random variable. But now, it's very important to know how to interpret this result. In other words, what does a mean of 4.4 actually mean? And to do that, let's try and give this exercise, as well as this probability distribution table, a bit of context. Let's say that the discrete random variable capital X corresponds to the value on which a spinning wheel stops. Something looking like this. Here's our wheel spinning. It has a little counter here on the right-hand side to indicate the number on which the wheel stops, and it's numbered 2, 4, 6, and 8, which are the possible values the discrete random variable can take. And so the experiment consists of spinning this wheel and making a note of the number on which the wheel stops spinning. So, given this context, this value, this mean of 4.4, tells us that if we were to repeat this experiment a large number of times, then on average, the value on which this wheel would stop spinning would be 4.4. Careful, that's an average. It in no way means that the wheel will stop spinning on 4.4. And that's quite clear since 4.4 is not one of the values the discrete random variable can take. No, it's an average. So if we were to spin this wheel 1,000 times or 100 times or 1,000,000 times, then on average, the number on which the wheel would stop spinning would be 4.4. Let me just add one last thing. The mean is often called the expected value, and that's the expected value of capital X, the discrete random variable. And we write it capital E in parentheses capital X. And to make things clear, that is the same thing as the mean mu. Now, the term expected value can sometimes be misinterpreted. It doesn't mean that each time we do this experiment, we can expect the discrete random variable to equal to 4.4. No, the term expected value refers to the value that we could expect to get on average for the discrete random variable if we repeat this experiment a sufficiently large number of times. And there we have it. That's it for the mean and the mode, everyone. I really hope this video helped, and if it did, please hit like on this video and even subscribe to our channel because that really does help us. I'll see you soon.